Okay, we'll come back again. After we have found the exponential form of z that can be written as cosine theta plus I sine theta, and let's call this one z1 and z2 cosine theta minus I sine theta, we have found this one as e to the I theta, and this one e to minus I theta. Okay, now it's time to find this one, minus cosine theta minus I sine theta. Remember that the Euler definition for the cosine that we will prove definitely is given by this, and the sine is given by this. So e to I theta minus e to minus I theta over 2I. Okay, and remember that e to I pi is minus 1. Okay, so we can use it from here or from here. So here, so this is minus 1 plus I times 0. Okay, and using this one here, we can see it. E to I pi over 2 is I, using here, chill. Okay, now we see that our complex number z3 is minus cosine theta plus I sine theta. Okay, but we know this one from here. So this is minus e to I theta. Okay, but first we need this norm here. So z3, the norm of z3 is just minus cosine theta squared plus minus sine theta squared. And this gives us cosine theta squared plus sine theta squared. And we know this is the square root of 1, which this is 1. The square root of 1 is just 1. Okay? So because why we need to compute the norm? Because in complex, in exponential form, every z can be written as the z is the norm of z e to some alpha. Okay, some angle. But here we found that z3 equals minus e to I theta. The norm is 1, but we need to get rid of this minus. This minus is e to I pi times e to I theta. Okay, and using the rule of exponents, this is e to theta plus pi. So that means our z3 is this one. We will see why it has this form. After we finish these videos, we're gonna give a geometric explanation for this. All these numbers, z1, z2, and z3, they have this property that they have norm 1, but the only thing that's changing is this argument. Okay, note that z1 has argument as theta. The second one is e to I minus theta. It has minus theta. This third one is theta plus pi as argument. We will see what we mean by that. For now, one need to remember these formulas here, and remember that the exponential form is z, can be written as z, the norm of z times e to some alpha, okay, some angle. That angle is the argument of the complex number. Okay, so we found that z3, which is minus cosine theta minus I sine theta, is e to theta plus pi. Okay, so this is the exponential form. This is the exponential form in our number in this case. Thank you very much.